So now that we know some of the basic sets and we've learned our set notations, we want to practice moving back and forth between the different notations. So the first question here, part A says, give the roster notation, or again, the list notation is what that means. So list the elements of the set A, and A is the set of x's such that x is an integer, and that's because that's what that symbol means. And x is greater than 0 and also less than or equal to 100. So the endpoints, the end values start to really matter on these, on whether you include a value or not. So we would call this exclusive, or we would say it excludes 0. 0 does not belong in this group because it says x's have to be strictly larger than 0, but it is inclusive of 100. So those are some other terms that you may need to use, especially if you're needing to describe these. So it's basically all of the integers between 0 and 100, exclusive of 0 and inclusive of 100. So how we could write this, remember we want to list it. So we say A is the set, and we always write sets in these braces. And I want to start listing these integers. So 0 does not count, but 1, 2, 3, and I'm clearly not going to list these all the way up to 100. So I would use those ellipses to show that it's going to continue in this manner. And then my very top value is 100. Maybe I include, this isn't necessary always, but it's nice to sort of include maybe 1 or 2 values at that top end to just, again, show it continued in this manner, counting the integers up to 100. And we included 100 in this. Okay, so let's reverse this now. It says give the set builder notation for this set B 2, 3, 5, 7, and 11. So I think going this direction is quite a bit harder because they've listed the elements, and you have to figure out how to describe those elements. So this could take some thought and some real thinking and some work. It's easier to have a description and then list them, but to have the list and describe them is harder. So what is it about all these elements? I can say, well, these are all rational numbers. They could all be written as fractions, but more than that, they're all integers, and they're actually even all natural numbers. But there's something else very special about these. There's something going on, like why is it those numbers? And what I notice about those numbers is I notice that they're all prime. These are all prime numbers. So I might write this as B is the set of x's such that, and then I have to describe these. So maybe I say x is a prime number and then I need to describe that. So it's not all the prime numbers, right? There's a top to this. So it's a prime number. I could either say less than or equal to 11, maybe. So I could say that. But notice there are multiple ways I could describe this. I could say B is the set of x's such that x is a prime number that is, and maybe I could say less than 13. So if it's strictly less than 13, that would mean that 11 is the largest value. Or I could switch the symbols and say less than or equal to, and then stop it at 11. So when you're given, if you're making your set builder notations, you usually have options of how you want to write it. Of course, if it's a multiple choice question, you're going to have to pick the one that they give you that actually fits. But if it's an open-ended type question, there technically are multiple ways usually to write these set builder notations. Okay, so give the set builder notation for the set C, whose elements are 1, 4, 9, 16, and 25. So what stands out to me about these is that those are all perfect squares. So I might write that to myself. And then, okay, how am I going to then write that in the set builder notation? So C is the set of x's such that I could simply just write x is a perfect square. And then I could say less than or equal to 25 or something like that. Also, a way you might see these written, just because this is another way that you'll see them, a lot of times they'll say, this is the set of all the squares. Like they just say it. This is the set of all x squareds such that x is, I'm going to say, less than or equal to 5. So they might say this is 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. So they might describe it like that. This is the set of all x squareds such that x is some number less than or equal to 5. Or maybe even on this one, we might have to say such that x is, and it might even be better to say 1 is less than or equal to x is less than or equal to 5. This is probably a better way to say it so that we don't imply that maybe there are negatives, right? Because if I square the negatives, I could get some values higher than that. So this is probably a better way to say it. But you can see how you have to be very, very careful in how you say it. Okay, let's move on. Give the roster notation. So, okay, this should be a slightly easier one because we're going back to listing. For the set D, whose elements are all of the letters that make up the word statistics. Okay, so D is the set, and I have to list all of the letters that make up the word statistics. So here we're going to get into something interesting. So letters in statistics are S, T, A, and then I'm not going to list the T again because I don't double list when I'm making sets. And I need an I, but I've already used the T, I've already used the S, T, I, so the only one left is a C. So this brings up a couple important notes. We don't double list elements. And also the order of the elements doesn't matter. This would be the same set if I mixed those numbers all up because it's just a set, it's just a list of these letters and the order of them doesn't really matter. So that one wasn't too bad. Oh no, another set builder one. Okay, give the set builder notation for set E, which contains all of the real numbers between 18 and 21 inclusive. Okay, so we have to build this set. So it's the set of all x's such that if they say it's real numbers, then you're going to want to include that x is an element of the reals part here. And these are all the numbers between 18 and 21 inclusive. So they've used that word inclusive, which means we're going to include both of those endpoints. So I would write something like 18 is less than or equal to x is less than or equal to 21. So that would include both of those values. And notice there would be no way to actually list all of those out. I cannot, it's not possible to list all of the real numbers between 18 and 21 because there are an infinite amount of fractions and decimals in between there, and I could never list them all. So set builder notation is the best we can do there. The best we can do is describe them. Give the roster notation for F is the set of two x's such that x is an element of the integers. Okay, so let's remind ourselves, integers are the -2, -1, 0, 1, 2. So those are the x's, but specifically for set F, we're writing all of the 2x's. So basically we need to take every integer and multiply it by 2. So it looks like there's going to be another infinite set, and all these numbers multiplied by 2 would be -4, -2, 0, 2, 4, and so on and so forth. So really what they've described to us there is F is the set of, is the set of all even integers. All right, once you multiply all of the integers by 2, now they're all even. Okay, then you might get questions like these where they might say, is 15 an element of some set? So let's go back and remind ourselves, what was set A? Set A was all of the integers between basically 1 and 100. So would 15 be included there? Sure, it would. Like I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 would be there. So I could say yes. Oops. X is an element of set A. Is 15, oh, I'm sorry, that means 15, not X is, yes, 15 is an element of set A. Is 15 an element of set F? Okay, so F is the one just right here that we did. So F, we said, basically is the list of all even integers. So is F an even integer? No, it's not. So I would say 15 is not an element, which we write as element symbol with a slash through it, of F. So 15 is not an element of F.